for our next problem, we have work done in pumping liquids to level of discharge. So work, or the W, is just gamma V h bar. So h bar is the vertical distance of the centroid of the figure, of course, with respect to the level of discharge. And V, of course, is the volume of liquid. Okay, so this is almost just the same with the last one. The difference is you will just replace the A with V. Okay, so let's try this one out. So for number one, we have a hemispherical tank is 6 meters across the top. Okay, so we can have here 6 meters. See 6 meters, right? Um, 6 meters across the top and full of water. Okay, so the hemispherical tank is full of water. So find work done in pumping the water just on the top of the tank. Okay, so if that is a hemispherical, again, hemispherical is just one half of a sphere. So we can easily get the volume of that. So the only problem here is the h bar. So for the h bar is the centroid. The centroid for this one is just, so the distance of the centroid of the sphere to the top of the tank. Okay, so this is just 3/8 r. Okay, 3/8 r. So the volume and the work done now is just, again, that is gamma h bar v, right? And then so gamma now is 9.81 again, okay? 9.81 a kilonewton per cubic meter, okay? Times the h bar, okay? So the h bar now is just 3/8, right? 3/8 r. The diameter is 6, therefore this is just 3. Okay? Times the volume of the hemispherical, which is the volume of a sphere is 4/3 pi r cube. Since we are looking for the half of that, so it will become 2/3 only. Pi r, so this is 3 cube. Okay, 3 cube. And the answer for this one is simply 624.09 kilojoules. It, okay, so for number 2, we have a trough 6 meter long, has a parabolic end sections. So this is 6 meters. 6 meters end section, which are 1 meter wide. So this is, I already drew a separate end section. So this is a trough again, and the end sections are parabolic. So the end sections which are 1 meter wide, so this is 1 meter, and then 1.5 deep. Okay, 1.5 meters deep. So that will be the height of the parabolic section or the parabola. Deep is full of water. Okay, so the trough is full of water. So find the work done in pumping the water to level which is 2 meters above the tank. 2 meters above the tank. Okay. So again, the formula is just work done is just the gamma V h bar. Okay. So we already have the value for the gamma. So for the volume, all you have to do is just get the volume of the parabolic section, which is 2/3 base height. Base is 1.5, and no, height is 1.5, base is 1. But we are looking for the volume. Therefore, you have to still uh, multiply this by the length, which is 6. So times 6. Okay, so that will be your volume. How about for the h bar? Okay, so for the h bar, again, if this is the centroid, okay, so if that is the centroid, again, this will be your, this is 2/5. Okay, this is 2/5. And then the remaining will be from here, this is 3/5. H, H. For the h bar, so that is 2/5 times the height. So height is 1.5. But remember that this is just from the centroid of the parabolic section or the centroid of the trough to the top of the water or the top of the trough. And you still have to pump it 2 meters above the tank. Therefore, you must have here plus 2. Okay? So, combining all of that, you'll just have your work is equal to the 9.81, okay, a kilonewton per cubic meter. 2/3 times 1.5 times 1 times 6, okay, times the h bar, which is 2/5 times 1.5 plus 2, okay. And then combining all of that, you'll just have here 153, 1 153.04 kilojoules. And this will be your answer.